Hello students, in the previous video we talked about distance time graph, and we also studied how this graph is used to express the different types of motion. Okay, so we studied that if the graph is a straight line, it is uniform motion. If the graph is an uneven line, then it is non-uniform motion. If the graph is a curve, then it is acceleration. Okay, so this is, and if the graph is a straight line which is parallel to x-axis, then it is in rest position. The object is in rest position, that means no motion. So this is what we studied yesterday. Okay, uniform motion, non-uniform motion, acceleration, and the object is in rest position. Now one more thing over here to understand is that if the graph is a curve but in the other direction like this means that in the beginning it was covering more distance, but then it slowly, as the time progressed, it covered less distance, and ultimately it came parallel to the x-axis. That means it has come to rest. So such a type of graph is deceleration, in which it is covering less and less distance, and therefore it is deceleration, its velocity is decreasing. So acceleration is a curve in that direction and deceleration is a curve in this direction. Okay, moving forward, the most important use of this distance time graph is that we can find the velocity of an object. Okay, so suppose the object is moving in uniform motion. And we have a graph to describe it as shown over here. So for example, I am giving you a few values. Okay, we have a graph over here describing the uniform motion of an object. I will write a few values. So over here I have written the distance covered, that is 10 meters, 20 meters, 30 meters, 40 meters, 50 and 60 meters. And on this over here, wait, I will zoom the values for you a little bit. Okay, and over here we have time in 0.5 seconds, then 1 second, 1.5 seconds, 2, 2.5 and 3. So because this is in uniform motion, all the points over here coincide with each other. That means at 0.5 seconds the object covers 10 meters. After another 0.5, that is 1 second, it covers 20 meters at 1.5 seconds. So time interval is 0.5 seconds, as you know already. 0.5, then 1, then 1.5, then 2, then 2.5 and 3. And for that we have corresponding values over here. So the question asked is, what is the velocity or speed of this object? We need to find the velocity of an object. So as you can see, it is a straight line, that means object is in uniform motion. If the object is in uniform motion, you can find the velocity by taking any 2 points on the graph. Because this is uniform motion, whichever points you choose, it will always be going to be the equal velocity, because if the object is in uniform motion, we know that velocity is constant. So choose any 2 points on the graph. Choose any 2 points on graph. Any 2 points on graph. So for example, over here I am choosing this one, that is 50 meters, and over here 20 meters. So first point is 50 and the next one is 20, or you can say 20 and 50. So this is the initial point, this is the final point. So the distance covered in between is, so we know the formula for speed or velocity is displacement upon time. Okay, so over here I am taking point B and A and B. So the distance or displacement is S2 minus S1. What is the distance or displacement between the 2 points? I am taking this point S2 and this point as S1. So S2 minus S1 will give me the displacement in between. And on that, what is the time taken for the object to move from point S1 to S2. So what is the time taken? So it will be T2 minus T1. Time taken and distance in between. So S2 is 0.50 minus S1 is 20, and for that respective time, for S2 it is 2.5 and for S1 it is 1. So I am writing over here 2.5 minus 1. So I have written all the values, that is 50 minus 20, S2 minus S1, and for S2 we have 2.5 second and for S1 we have 1 second. So we get the distance in between the S2 and S1, that is 30 meters, and the time taken, that is 2.5 minus 1, that is 1.5. Okay. In order to remove the decimal point, we multiply it by 10 and the next value becomes 300 by 15. So 15 2's 30 and 0 as it is. So what you get is 20 meters per second. So this is your answer. This is how you are supposed to solve or find the velocity of an object which is in uniform motion using distance time graph or displacement time graph. If the object is in uniform motion, then you can find the velocity by choosing any 2 points on the graph given, and for that given or finding that points, you can choose the respective time of it. So you get the time taken from point S1 to S2, and the distance between S1 and S2 is 30 meters. So 20, then 10, that is 30, then 20, that is 40, and then 30, that is 50. So the distance is 30 meters and time is from 1 to 2.5, that is 1.5 seconds. So we have the time and the distance, or simply you can use this S2 minus S1 upon T2 minus T1, and what you get over here is 50 minus 20 is 30, 2.5 minus 1 is 1.5, and ultimately you get the answer, that is 20 meters per second. So this is how you find the velocity of an object which is in uniform motion using displacement time graph. Okay students, so here is a question for you. You can solve it. The question is, the object is moving in uniform motion. Simple, find the velocity of this object. We will solve it afterwards, but this is the question for you, so you can solve it at your own time. Okay, over here we have distance in meters and time in seconds. Okay, pause the video and draw the graph yourselves and try to solve the equation once again. For this we will also solve another question over here in this video, so it is much easier for you to understand. Okay, let me draw the question for you first and then we'll continue. Okay students, so here the question is, the graph has been given for you and we have been given different points, that is point A, B, C and D. The question is, the graph shows the positions of the body at different times and calculate the speed of the body as it moves from point A to B, then B to C and C to D. Okay, so we have to find speeds for the object at these different intervals. So points have already been given to you, okay, and you need to find the speed. So in the first case, what you have to do is, find the speed between these 2 points. Again the same formula, so speed is distance traveled upon time taken. So this is the final point and this is the initial point, so we will write B minus A upon time taken. So as you can see, at point B we have 3 meters minus A, that is 0. Okay, and time is 5 and 2, so we will write 5 minus 2, so it becomes 3 upon 5 minus 2 is 3. So the answer is 1 meters per second. So the object is moving with 1 meters per second. There you have it, quite simple. Point B minus point A, the time is 5 seconds, and at A time is 2 seconds, because over here it is time, and the distance is 0 meters. So at 2 seconds it is starting from 0 meters and going to 3 meters. So we have write 3 minus 0 over here. So the first problem is solved from A to B. The question has been solved. The second part of the question is from B to C. As you can see, from B to C, it is neither going towards the y-axis or either it is moving to the upside. That means it is a straight line which is parallel to x-axis. That means the object is at 3 meters. It has not moved to 4 meters or it has not come back to 2 meters. So from 5 to 7 seconds, the object is at the same 3 meter distance. That means it has not moved. And like I said yesterday, if the object has a straight line in its graph, that means it is not moving, it is in rest position, this case. So over here the same thing is happening. So at B to C, in order to solve it, we can write C minus B, where it is 3 meters minus 3 meters, and upon time, that is 7 minus 5. So time is 7 seconds minus 5 seconds. So we write 3 minus 3 is 0 upon 7 minus 5 is 2. So it becomes 0 meters per second. That means its velocity is 0 because it is not moving, and therefore its velocity is 0. Quite simple. Okay. Pause the video and watch the numerical once again. And finally, we move on to the last point, that is from C to D. Okay. So from C to D. So we will write speed as distance d minus c upon time taken. So d is how much? 8 meters. So we will write 8. C is 3 meters. So we will write 3. Upon time for d it is 10 seconds and for c it is 7 seconds. So we will write 10 minus 7, that is 8 minus 3 is 5 and 10 minus 7 is 3. So what you get is finally 5 upon 3, or you can write 3 ones is 3, 2 is remaining, so 3 6 is 18. So what you get is 1.66 meters per second. It's that simple. Moving from C to D, we have S is equal to D minus C upon T. At D it is 8 meters, so we are writing 8, and at C it is 3 meters, so we are writing 3. So 8 minus 3 is 5, and for that time taken for D is 10 seconds and for C it is 7 seconds. So we'll write 10 minus 7, so it is 3. So 1.66 meters per second. Okay students, so if you compare this question to our question, it is quite simple. I have just asked you to find the velocity. In this case you can choose any 2 points and find the respective distance and find the respective time for it. Quite simple. Okay, so what we have studied today? We studied that using distance time graph of an object which is in uniform motion. Remember, this velocity can only be found out if it is in uniform motion. So using distance time graph of an object in uniform motion, we can find the velocity of the object by choosing any 2 points on the graph. Okay, this is what we have studied, and this is the example of the numerical that we solved today. Okay students, remember this. Try to revise different topics from the previous videos as well, as they are going to be quite complicated terms coming in the next videos. So it is better if you remember all the previous terms that I have taught you, that is distance and displacement. And in the next video we will start with a new point that is quite similar to this one, but a little bit different. Like I said, distance time graph is done. So in the next video we will study about velocity time graph. Okay, so in the next video we'll study about velocity time graph, and then we will move on to the acceleration in velocity time graph. Have a wonderful day.